Hi there, folks. This is the Unit 5 review, and I am the amazing Mr. Jansen, so away we go. If we look at these first two, they ask us to find the slope of the line, then the slope of the parallel line, and then the slope of the perpendicular line. So this first one, if we're given 2 points, we're just going to use our slope formula. So I just do y2 minus y1 over x2 minus x1. And again, just be careful with your signs here, especially as you're subtracting and you're dealing with negatives. This becomes adding the opposite, this becomes adding the opposite. So I end up with what looks like a 10 over 5, which is a 2. Alright? So if that's the slope of my line, if I start talking about the parallel line, remember parallel lines have the same slope, so that's also going to have a slope of 2. And then perpendicular lines, the slopes are opposite reciprocals. So 2 is like 2 over 1, so if I change the sign and flip it, I go from a positive to a negative, and then when I flip that 2, it gives me a 1/2, so it's a negative 1/2. Remember, opposite reciprocals, you've got to change the sign and flip it. Alright? The next one, we just kind of do our change in y over change in x, or rise over run here. So the rise actually takes us down, and then the run takes us over. So we just count how far down. It looks like 1, 2, 3, 4, 5, 6. So we went down 6 units this way. We went over 3 units this way. So again, when we do our slope, rise over run, that's an ugly looking M. Let me try again. Rise over run, it was down 6 and then over 3. So this time we get a negative 2. So the parallel line is also going to have a slope of negative 2. The perpendicular line this time will have a slope of positive 1/2. Okay? Again, we change the sign and flip it. So we get a 1/2. Alright? If we look at the next one, it says to find the x and y intercepts. Remember, visually, when we're looking at a graph, the x-intercept is where it crosses the x-axis. So right here, it crosses the x-axis at negative 5. And again, I'm always going to write it as an ordered pair. That's the ordered pair negative 5, 0. The y-intercept is where it crosses the y-axis. So right here, crosses at positive 4. And again, I'm going to write it as an ordered pair. That's the ordered pair 0, 4. Alright? It's always better to think of these in terms of ordered pairs. We always want to write them as ordered pairs. It's better in the long run, and it makes the most sense algebraically. So when we look at the next one, algebraically, the x-intercept is when we plug a 0 in for y. The y-intercept is when you plug in a 0 in for x. And you can see that in the ordered pair I just wrote. The x-intercept, negative 5, 0. The x value is negative 5. The y value is 0. The y-intercept, the x value is 0. Okay, so it's showing us what we're plugging in for x or y. So again, with this one, if I were to plug a 0 in for y, that gives me 2x equals a negative 18. If I were to plug a 0 in for x, that gives me a negative 6y equals a negative 18. Alright? And now I just have to solve each of these. So here I divide each side by the 2. So I end up with x equals a negative 18, or sorry, a negative 9. And again, I want to write that as an ordered pair. It's negative 9 for x, but that was when I plugged a 0 in for y. Alright? Over here, I'm going to divide each side by the negative 6. So I end up with y equals a positive 3. And again, I want to write that as an ordered pair. I plugged a 0 in for x, and I got a positive 3 out for y. Okay? And that's it, x and y intercepts. Down here it says to give the equation line in slope-intercept form that's parallel to y equals a negative x plus 1 and passes through the point 2, 1. So again, if I want to write the equation in slope-intercept form, I'm going to go the route of y equals mx plus b. I'm going to find the slope, and then I'm going to find the y-intercept, and then I'm going to plug them in. Okay? You can also do point slope here, where you find the slope, plug it into point slope, and then rearrange it to put it in slope-intercept form. But again, this one's asking for slope-intercept form, so I want my final answer to be in y equals mx plus b. Alright? So the first thing I need to do is think about the slope. I always find the slope first, and when I think about this line, the line that has been presented to me has a slope of negative 1 because it's in slope-intercept form. Alright? If I want my line to be parallel to that line, remember parallel lines have the same slope, which means if that line has a slope of negative 1, I want my line to have a slope of negative 1 as well. Alright? So once I identify the slope, I follow this process. I start with y equals mx plus b, because that's the format that I want, and I'm going to solve this for b, so I just start plugging in what I know. I know the slope is a negative 1. I have an x and a y value, and I want to solve for b. Here's my x and my y over here. So I plug the 2 in for x, I plug the 1 in for y, and now I'm going to solve for b. So here that gives me a negative 2 plus b. I'm going to add the 2 to each side in order to solve this thing. So I find out that b equals a 3. So now I have the slope, I have the y-intercept. When I write the equation, I just plug those two elements in, so I've got negative 1x plus 3. And you can leave it like that. I'm going to go ahead and make that 1 invisible to make it a negative x plus 3. Is typically how you're going to see it. If you leave the 1 in there, that's fine. All right. For the next one, give the equation of the line in point-slope form this time. So this time we want point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1. And it says that travels through 4, negative 2, and is perpendicular to y equals a 2/3 x minus 3. And so again, when I think about the slope of the line that has been presented to me, this line has a slope of 2/3. So I want a perpendicular line, which means my line has to have a slope that's the opposite reciprocal, so a negative 3/2. Okay, change the sign and flip it. So that's my slope. And now from here we just plug it into point slope form. So y minus y1 equals m times x minus x1. And that x1, y1, that's your ordered pair. So right here is x1 and y1. And I just plug them in. So let's see, I've got the negative 3/2 goes in here. I plug the 4 in here. And then over here I have minus a negative 2. Well, the last thing I have to do is I just have to clean this up a little bit. And most of us plug this in and immediately change this to addition. So my final answer here becomes y plus 2 equals negative 3/2 x minus 4. Okay? And that's it. All right, that's in point slope form. I don't need to take it any further than that. And again, if this had asked for slope intercept form, I could take the same approach, and then I would be distributing the negative 3/2 and subtracting the 2. Okay, that's how I get to point slope form. But that's how I get to slope intercept form. This one just asks for point slope, so I leave it that way. Okay. The next one, it says give the equation line in slope intercept form that has the following points. So again, once again, I'm going to do this the other way. Again, you can use point slope here and rearrange it. I'm just going to go right to y equals mx plus b. So I'm going to find the slope, find the y-intercept, plug it in. So I'm going to find the slope, find the y-intercept. So to find the slope here, because I'm given two ordered pairs, I'm going to use my slope formula, y2 minus y1 over x2 minus x1. And once again, be careful with your signs here. Subtracting is adding the opposite. And so what I end up with here is I get a negative 7 over a 4. So that's my slope. Now I'm just going to find the y-intercept by starting with a fresh y equals mx plus b. And I just plug in what I know. And it doesn't matter which of these ordered pairs I use. Maybe I'll use this first one for my x and my y value. So I just start plugging in, and I say, okay, I'm going to plug the negative 7/4 in for m. I'm going to plug the negative 1 in for x, and I'm going to plug the 2 in for y. All right? And now it's just a matter of solving this for b. And so here I get a positive 7/4 plus b. From here I can subtract that 7/4. The issue with that is many of us don't like dealing with fractions. So go ahead and subtract that 7/4 if you don't mind dealing with that fraction and doing the 2 minus the 7/4. But again, since I'm solving an equation now, if I want to solve an equation, I have fractions in it, I can always do this trick of multiplying each side by the common denominator. And so as I multiply through on this thing, I end up with 8 equals 7 plus 4b. All right? The fractions automatically go away, and now I can solve this thing pretty easily. I subtract the 7 from each side, that gives me a 1. And now I divide by the 4. And so I find out that b equals a 1/4. So now I have the slope, I have the y-intercept. To write my equation, I just plug those two things in. Y equals a negative 7/4 x plus 1/4. Okay? Don't be afraid to deal with fractions, or if you have an equation, eliminate the fractions by multiplying through by the common denominator. Okay? The next one, we want this thing in standard form. Remember, standard form is ax plus by equals c. And the thing about standard form, yeah, we got to get x and y on the same side. It has to be x, y equals constant. But we're not allowed to have any fractions, and we're not allowed to have a negative out front. Okay? So I'm going to get everything on the same side first, get the general format, and then I'm going to take care of the fractions and the negative. All right? So from here, I got to get the x over on the same side as y, so I'm going to add that 2/3 x to each side. So over here I get a 2/3 x plus y equals 4. And now from here I've got it in the right format, which looks pretty good, but now I just can't have any fractions and I can't have a negative out front. So to get rid of the fractions from any equation ever, I multiply through by the common denominator. So I multiply each side by 3 to get rid of these fractions. So here I distribute, that gives me a 2x plus 3y equals 12. And I don't have a negative out front, so this is good to go just the way it is. Okay? The next one, write in slope-intercept form. Remember, slope-intercept form we've already dealt with a couple times here, but slope-intercept form once again is y equals mx plus b. And slope-intercept form is nice because no matter what format we're in, all we have to do is solve for y, get y by itself, and it'll automatically be in slope-intercept form. So to get y by itself, I would need to add this 2x to each side. So that gives me 3y equals 2x plus 10. And now I divide each side by the 3. So over here I'm left with y. Over here I have to utilize my distributive property. Even though I can't really reduce either of these, I still distribute 2 divided by 3 as a 2/3 x. And then 10 divided by 3, I'm just going to leave as 10 over 3. And that's it. This is in slope-intercept form. I have my slope, I have my y-intercept. Okay? The next one, it says determine if the lines are parallel, perpendicular, or neither. And so what I need to do here is I need to put these in a format where I can see the slope. All right? And the thing is this. If the lines are parallel, the slopes will be the same. If the lines are perpendicular, the slopes will be opposite reciprocals. If the lines don't have the same slope or don't have opposites, neither of those, then it's neither. All right? So I'm just checking to see if the slopes are the same or see if the slopes are opposite reciprocals. All right? So as I look at this thing, this very first equation here, this guy is already in a good format for me. It's in y equals mx plus b, so I can tell that the slope is 2. All right? The second one, I can't tell what the slope is. It's not in the right format, so I'm going to put it in slope-intercept form. That's typically the one I want to head towards. Because it's the easiest one to find. You just solve for y. So I'm going to subtract the x from each side. So that gives me a 2y equals negative x minus 10. And now I'm going to divide each side by 2. Once again, I'm going to use my distributive property here. So really this is a negative 1x divided by 2. So negative 1 divided by 2 is a negative 1/2. And then I put my x down. Negative 10 divided by 2 is a negative 5. And so now that I have this in slope-intercept form, I can identify the slope. So when I look at this thing, I can see that it has a slope of negative 1/2. So I look at the two slopes that I have. I've got a 2 and a negative 1/2. They're not the same, so it's not parallel. But they are opposite reciprocals. One's positive, one's negative, so they're opposites. One's a 2 over 1, the other one's a 1 over 2, so they're reciprocals. They're opposite reciprocals, which means that these two lines are perpendicular. Okay? And that's it. We're just working it to a point where we can compare the slopes. Okay? If I look at the next one, these are already in a format where I can identify the slope. If I look at that first one, it's already in slope-intercept form. And so when I look at slope-intercept form and I think about the slope of this thing, it's 3/4. When I look at this guy in slope-intercept form, I can tell that the slope is 4/3. And so I look at these and say, are they the same? The answer is no. That's not the same slope. It's not the exact same number, so they're not parallel. And then I look at them and say, are they opposite reciprocals? And while they might be reciprocals, they are reciprocals. One's 3 over 4, the other one's 4 over 3. They're not opposite reciprocals. They have the same sign. So they're not perpendicular because they're not opposite reciprocals. So because they're not parallel and they're not perpendicular, I can safely say that these are neither. Okay? Because it didn't follow the criteria for either parallel or perpendicular, it's neither. And I move on to the next one. Okay? And so in the last one here in this section, I look at this first one is already in slope-intercept form, so that one's got a slope of 3/2. The next one's not in the right format, so I'm going to put it in the right format. I'm going to put it in the y equals mx plus b format, so I'm going to subtract the 3x from each side. That gives me a negative 2y equals negative 3x plus 6. And now I'm going to divide each side by the negative 2. So I end up with y equals, I have to use my distributive property once again, negative 3 divided by a negative 2, negative divided by a negative is a positive, 3 over 2 is just 3 over 2. And then 6 divided by negative 2 is a negative 3. And so as I look at this thing, I can see the slope now for this guy. And the slope of this one is 3/2. So I look at the two slopes and ask myself, are they the same? The answer is yes, they're exactly the same. So that means these two lines are parallel. Okay. The next couple asks if these are represent direct variation, and if so, what's the constant of variation? Remember, direct variation is basically a y equals mx plus b type of equation, but it has a y-intercept of 0. So it's a line that goes through the origin. All right? And remember, direct variation is always of the form y equals kx when we look at this thing. So we're just going to rearrange it. We're going to solve for y and see if it's in the format y equals kx. Okay? So if I want to solve this first one for y, I go ahead and subtract the x from each side. And then I divide each side by the 4. I use my distributive property one more time, so that's a negative 1/4 x plus 1. And when I look at this, it's in y equals mx plus b format, but it has a y-intercept of 1. It doesn't go through the origin. It's not in the form y equals kx, so this one's not direct variation. Okay? So the answer is no for this one. It's not direct variation. If I look at the next one, again, same kind of thing. I want to solve for y, so I'm going to go ahead and add that 1/3 x to each side. When I do that, I get a negative y equals 1/3 x. I divide each side by the negative 1 to get y by itself. So I get y equals a negative 1/3 x. And when I look at this thing, it's in the form y equals mx plus b with a y-intercept of 0, so that means it's direct variation. It's a line that goes through 0, and I can see that it's in the format y equals kx. So then it says, okay, what's the constant of variation? Well, that's just the k value. So the k value on this one is a negative 1/3. So the answer is yes, the k value is a negative 1/3. This one's direct variation. Okay? If I look at this last one again, once again, I'm going to solve for x, solve for y. So I'm going to subtract the 3x from each side. I end up with a negative 3y equals a negative 3x. I divide each side by the negative 3. And I end up with y equals 1x. And so this is in the format y equals mx plus b with a y-intercept of 0. So that makes it in the format y equals kx. So this one is direct variation. And the k value this time is 1. Okay? This next one says, suppose y varies directly with x. In other words, it's saying this is going to be direct variation. This thing is going to be in the format y equals kx. All right? And if I want something in the format y equals kx, really the only thing I need to know is what the k value is. All right? So then it tells me y equals 5 when x equals 10, and it wants me to find another y value given a different x value. And so here's the thing, when it tells you that relationship between x and y, it's basically giving you a way to find your k value, to find your constant of variation. In other words, if I know this thing is in the format y equals kx, and I know that if I plug a 5 in for y, I'm going to get a 10 out for x, I can now figure out what my k value has to be to make that happen. And so here I just solve for k, so I'm going to divide each side by the 10. So I find out that k equals 5 over 10, which reduces to 1/2. Okay? And so what happens here, now I have my k value. So in other words, this particular equation, or this particular relationship, is going to be described by the equation y equals 1/2 x. So I find the k value, then I write the equation, my direct variation equation, and then the last thing I have to do is use that direct variation equation. Okay? So I find k, I find the equation, and now I'm going to use that equation. If I know I have the equation y equals 1/2 x, well, now I just need to plug a 13 in for x and see what y equals. So that gives me y equals a 13/2, or you could write it as a 6 1/2. All right? Either one of those would be an acceptable answer. Okay? The next couple, we're just graphing these. And so again, when we're graphing these things, the first thing you need to do is determine, okay, what format is this thing in? And then once I know the format that it's in, I can determine what the best method for graphing is going to be. All right? So when I look at this first one, it's in the format y equals mx plus b. In other words, this is in slope-intercept form. So I'm going to make a note of that here. So this is slope-intercept. And whenever I have slope-intercept, the reason it's called that is because it gives me two things, the slope and the y-intercept. So here's my slope of -3/2, here's my y-intercept of 1. So it gives me a point at which to start and then a slope in order to find more points on this graph. Okay? So I start at the +1, that's my y-intercept, and then I use that slope of -3/2, so down 3/2. And I can keep going down 3/2, or you can go up 3 back 2, and now I draw my line. Okay, and that's it. The next one, this one's in standard form, so when I see this one, it's in standard form. And probably the easiest way to graph things when it's in standard form, really you have two options. You can rewrite this in slope-intercept form by solving for y, or you can find the x and the y-intercept, and that's the route that I would go. I'm going to find the x and the y-intercept, so to find the y-intercept, I just plug a 0 in for x, which gives me this. And then to find the x-intercept, I plug a 0 in for y. To find the y-intercept, I plug a 0 in for y, which gives me the -4x equals 8. To find the y-intercept, I plug a 0 in for x, which gives me the 2y equals 8. Again, I just plug a 0 in for each, and now I'm going to solve. So here, I divide each side by the -4. So I find out that x equals -2. And once again, I'm going to write that as an ordered pair. Let me scoot this guy out of the way. Let me write him just a little bit lower. So I write this as an ordered pair, that's -2, 0. And then I plug my 0 in for x, and I solve for y. So I'm going to find the y-intercept here, divide each side by 2. And I find out that y equals 4. Once again, I write that as an ordered pair, that's 0, 4. And now I just plot each of those. -2, 0 is right here. 0, 4 is right here. And I can even see the slope as I look at this thing. I want more ordered pairs. I can count the slope on this thing. I go up 4 and over 2, so the slope is 4/2, which is 2. And so I can use that to plot more ordered pairs on this thing. So I've got my x and y intercept. Now I could go up 2/1, up 2/1, up 2/1, or down 2, back 1, down 2, back 1. Draw this line. Okay? Look at the next one. The next one says just y equals a -2, and this isn't really in any of our formats. This is a special format because this is either a vertical or a horizontal line. And so when we look at this thing, again, y equals a -2. Y equals is always a horizontal line, so this one is going to be a horizontal line. And so when we draw this horizontal line, I go to -2 on the y-axis, and I just draw a horizontal line. When we think about this, this is the one we tend to really mess these up in terms of x versus y. X equals is always a vertical line, y equals is always a horizontal line. And the reason for that, think about the ordered pairs that are on this line. If I start thinking about the ordered pairs, like the ordered pair right here is 1, 2, 3, 4. That's the ordered pair 5, -2. The ordered pair here would be 4, comma, negative 2. The ordered pair here would be 3, comma, negative 2. The ordered pair here would be 2, comma, negative 2. The thing you should notice is that the y value is always negative 2, which is why it's the equation y equals negative 2. Okay? Next one, same kind of thing. This is in standard form, so I have two options. When it's in standard form, you either find the x and the y-intercept, or you can rearrange this one to make it y equals mx plus b. For this particular example, y equals mx plus b is actually a really easy option because all I have to do is subtract the x. And so the last one, I just went intercepts. This one, maybe I would subtract the x and do y equals a negative x plus 6. And so then I can say the y-intercept is a 6, and it's got a slope of negative 1. There's my y-intercept. Here's my slope of negative 1. The other option, once again, is to find the x and the y-intercept, which is also very, very easy on this one. Because here's the thing. If I plug a 0 in for y to find the x-intercept, when I plug that 0 in for y, it just leaves me with x equals 6. And then if I were to plug a 0 in for x to find the y-intercept, I get y plus 0, which is y equals 6. So I get the ordered pair 6, 0, and I get the ordered pair 0, 6. Well, if you think about plotting those, this gives me the same line that I already have. Okay? And when you look at the graph that I have, it does have a y-intercept of 6 and an x-intercept of 6. Okay? The next one, x equals a number, remember, is a vertical line, and we've already talked about this a little bit, but this is a vertical line. So I go to where x equals 3. I plot a point. Whoop, that's negative 3. Let me try again. X equals 3 is over here. And now I just draw a vertical line. That was a terrible line. Let me try again. I can do better. Okay? And when we draw this thing, again, think about the ordered pairs that are on here. This is why this is x equals 3. When you think about like this ordered pair, it's the ordered pair 3, 3. And you think about this ordered pair, it's the ordered pair 3, 2. This is the ordered pair 3, 1. You know, down here, that's the ordered pair 3, negative 1. When you look at the x value on each of these, it's always 3. That's why this is the equation x equals 3. Okay? And then this last one in terms of graphing, this is in point-slope form. And remember, in point-slope form, we're given a point and we're given the slope. Okay? So the point on this one, remember, is this guy right here. There's my x value, there's my y value. So this is 3, 2. Right? That's the point at which I'm going to start. And again, it's almost like we're taking the opposite of those because there's a minus sign built into the formula. And then the slope is right here. It's that 3 halves. So the slope is 3 halves. So I'm just going to start at the ordered pair that was given, the 3, 2. And I'm going to use the slope up 3 over 2, or down 3 back 2. Now I can draw my line. Ooh. Hit a little bit of a bump there. Let me try again. Okay? And here's the thing, when it's in point slope, you could rearrange this to make it slope-intercept, but in this one, that wouldn't be a good idea because look at my y-intercept. It's a fraction, it's some kind of decimal. That's going to be really tough to graph in a different format. So identify the point, identify the slope, and draw your line. This one says to find the missing value given the slope. And so if I want to find the missing value and I have the slope, I'm just going to do my slope formula. So again, once again, the slope formula is y2 minus y1. So y2 is 9 minus y1 is the negative 3. Over x2 minus x1, so that's just x minus 2. And when I do that, that should equal the slope, which is a negative 4 over 3. And so now it's just a matter of simplifying a little bit. This is like adding the opposite. So this gives me a 12 over x minus 2 equals negative 4 over 3. And now I'm being asked to solve. Well, to solve this, I'm just going to cross multiply. Okay, so remember when we're cross multiplying, I do this guy times this guy, and I write it down. Equals this guy times this guy, and I write it down as well. Okay? And I just have to solve this thing. I'm going to go ahead and do my distributive property, so I distribute. That gives me a negative 4x plus 8 equals the 36. I'm going to go ahead and subtract the 8 from each side. That gives me a 28, and then I divide each side by a negative 4. And I find out that x equals a negative 7. And that's it. All right. The next one, same kind of thing. The only difference is I'm solving for y this time, but I still do my slope formula and then cross multiply and solve. So I do my slope formula, y2 minus y1 over x2 minus x1 should equal my slope, which is a 2, which is the same thing as 2 over 1. So I do a little bit of simplifying, and then I'm going to cross multiply. Again, this is adding the opposite. That gives me a negative 5. And now I cross multiply. 2 times negative 5 is a negative 10 equals negative 4 minus y times 1 is a negative 4 minus y. And then from here, I'm just going to solve this thing. Let me rewrite it up here. So I'm going to add the 4 to each side. That gives me a negative 6. And now I divide each side by the negative 1. And I get y equals a positive 6. Okay? And I can easily check these by plugging them back into my slope formula to see if they give me the appropriate slope. Okay? Last one here, it says to start a lawn mowing business, you invest $1,540 in supplies and charge $55 per lawn. And so when I write this, I want to write an equation that models my profit. So I'm going to say y is the profits. And then I'm going to label my variable. I'm going to say x is the number of lawns that I mow. Okay? So if I make $55 per lawn, so $55 per lawn would be 55x, but I'm also going to subtract the money I already spent, the $1,540, so that's going to be my profits. Y equals the 55x minus the 1,540. Okay? And then here it says how many lawns must I mow in order to break even. That's when the profit is 0, so in other words, plug a 0 in for y. So if I plug a 0 in here, just asking me to solve this and see how many lawns I have to mow before I get my money back from all the money I spent starting the business. So now here I just solve. I'm going to add the 1,540 to each side. And now I divide by the 55. And that gives me 28. So it's saying I have to mow 28 lawns in order to break even. And then the last piece says, what does this break-even point represent in the graph? Well, I plugged a 0 in for y, so what I just found was actually the x-intercept. Okay? And that's it. Good luck on your test, and that's it.